Hello everyone, welcome to Zealand's class, and today it's our final part on trigonometry, and today we are going to deal with some other trigonometry problems. And now, there's an important thing that we should know. It is called expressing a sine theta plus b cosine theta into something like r sine theta plus and minus and another angle, or cosine theta plus or minus another angle. Well, why do we need to do this? Because sometimes when we are doing maximum values or minimum values, well, it's not easy to just find the maximum value and minimum value by using that. But you will find the maximum value of this, very simple. If we are trying to find maximum value straightly, we have to use calculus, and that is what we want currently. So we need to convert this form into like this form. So firstly, we don't know the value of r and the value of alpha. These two symbols have the fixed value. So let's try to find out what the fixed value is. And now let's start from the sine theta plus and minus alpha, which is a sine theta plus b cosine theta equals r sine theta plus minus alpha. And now we can use the double angle formula, which becomes r sine theta plus and minus alpha equals to, well, let's just do the plus because minus is the same thing, and this becomes r sine theta cosine alpha plus r cosine theta sine alpha. And this, we know that this is equal to a sine theta plus b cosine theta. And if we want to find out what the value of r in terms of a and b, then we can, because here we have a sine theta and here is a sine theta as well, and here is a cosine theta and here is a cosine theta as well. So we can say that r sine alpha, which is this part, r cosine theta, which is this part, is equal to a, and r sine alpha is equal to b. So we can get these two equations. And now if we want to solve the value for r, we know that cosine squared alpha plus sine squared alpha is equal to 1. This means if we square both sides, which becomes r squared sine squared alpha equals to b squared, r squared cosine squared alpha equals a squared. And we add these two equations, which becomes r squared sine squared alpha plus cosine squared alpha equals to a squared plus b squared. And this is equal to 1, which means r squared is equal to a squared plus b squared, and r is equal to positive negative a squared plus b squared. But most of the time the question will mention that r is greater than 0, so we can ignore the negative part, so we can say r is equal to a squared plus b squared and square root. And now you can do the same thing for cosine theta plus alpha, because, well, let's just do it. Let's do the same thing. Expand cosine theta plus and minus alpha, which becomes r cosine theta cosine alpha minus sine theta sine alpha. And now let's do the plus. And here we can do the same thing, which is r cosine alpha is equal to b, and r sine alpha is equal to a. Well, I mean, let's do minus. Okay, let's do minus. So we get plus here. And so we get r sine alpha equals to a. And now let's do the same thing. We will get r squared equals to a squared plus b squared. And r is equal to square root a squared plus b squared. And we get the same thing here. And let's solve for alpha. For alpha, how do we solve it? Let's call this equation 1 and let's call this equation 2. And let's use 2 divided by 1, which becomes r sine alpha over r cosine alpha equals to a over b. And we can cancel the two r's, and we know that tangent is equal to sine over cosine, which means this is equal to tangent alpha. And we know that alpha is equal to arctangent a over b. And same thing here, which you will also get, so that when we are dividing both of these, you will also get sine alpha over cosine alpha equals to b over a. And tangent -1 is b over a. So we know that so for this we can get that r, so for a sine theta plus b cosine theta is equal to square root a squared plus b squared bracket tan cosine bracket theta minus tangent arctangent a over b. And this is what we get. Although it looks like very complicated, but when you use the calculator to do the actual value, it will seem to be easier. So now let's move up to the questions. The first question is express 15 sine theta minus 8 cosine theta in the form of r sine theta minus alpha. And we know that r is greater than 0, alpha is greater than 0 and smaller than 90 degrees. So because we know that r is equal to square root a squared plus b squared, which means that it is equal to 15 squared plus -8 squared, and which is 17. So r is equal to 17. And because we know that alpha is equal to tangent -1 and b over a, which is 8 over 15. And alpha is equal to tangent -1 and which is equal to 28.1 degree. And we have solved this, which becomes 17 sine theta minus 28.1, and that is our answer. Okay, now let's move up to a harder question. Express cosine theta plus square root 3 sine theta in the form of this, where r is greater than 0 and alpha is greater than 0 and smaller than pi over 2. Well, we know that this is in radian form, so our alpha is also in radian form. So let's express this. The same thing. we know that r is equal to square root 1 plus 3, which is equal to 2. And for theta, well, for alpha, we know that this is equal to tangent negative 1 and square root 3 over 1, which is 60 degrees. And so we get r cosine theta minus 60 degrees. No, I mean 2. And because it's in radian form, which means we should leave 60 degrees into radian form, which becomes pi over 3. And here is also pi over 3. So now we have finished the first step. And now let's do the second step, which is an identity. So now we start from left hand side, which is 1 over, so the left hand side is 1 over cosine. Well, we can, because we have changed this part into this, so we can just write by using that. So we will get 2 cosine bracket theta minus pi over 3 bracket squared. And let's simplify this, which becomes 1 over 4 cosine squared theta minus pi over 3. And this is equal to 1 over 4 times 1 over cosine squared theta minus pi over 3, which is equal to 1 over 4 times secant squared theta minus pi over 3. And this is equal to right hand side. And we have done the problem. And that is all for today and all for the trigonometry part. And tomorrow we are going to start differentiation now. And thank you guys.